So let's just say you're taking the derivative of some function. Let's just do 0. Typically they use a, but whatever. We're going to do some function g of x, for example. So you have f of t dt. So whenever you're taking the derivative of this integral function right here, this is going to equal to f of g of x times the derivative of what's inside g prime of x. Now, you've been doing this entire time whenever you have a simple derivative of an integral function. So let's just say you have the derivative of something like this, 0 to the x of x t squared dt. Well, in this case, if we're taking the derivative of this integral sign, or if this integral right here, we already know that this is going to be just cosine of x squared because all we did was plugging the x into here. But what we don't normally do is we take the derivative of 1 at the end, or the derivative of x, which is just going to be 1. That's why we never write it. So that's the second fundamental theorem of calculus. This is something that we should know, that when you plug in whatever function in here, you have to multiply it by the derivative of the function that you just plugged in, or you substitute it into your input. Now, let me explain to you why that is. In other words, I'm just going to sort of prove it for you. Okay, so we're back in the very beginning. We have the derivative of this integral right here. Well, if we wanted to take the integral of this, remember, this is simply the antiderivative. So that's going to be capital F of t, and then you have to evaluate from 0 to g of x. What we're doing here is implementing the first fundamental theorem of calculus. We still have this derivative on this side. Well, you're going to go ahead and plug in g of x. So you have the derivative of, and then you're going to put capital F of g of x minus capital F of 0. And then now we're instructed to take the derivative of this. Well, we're going to start taking the derivative of this. According to chain rule, we take the derivative of capital F, which is simply lowercase f. We still have g of x times the derivative of what's inside, which is going to be g prime of x plus the derivative of this. Well, capital F of 0 is just a constant. When you take the derivative of the constant, that's 0, so that goes away. So look, this is exactly what I was mentioning. That's how we derive this formula right here. So whenever you're taking the derivative of some function, right, from 0 to g of x, then you have to do f of, and then your input is now going to be g of x, whatever that might be, times the derivative of what is inside. So let's review that again. Let's just say, for example, like number 31, we have the derivative from 0 to, let's just change it up. Let's go ahead and do like, let's do x cubed, for example, cosine of t squared dt. Well, if we're going to implement the second fundamental theorem of calculus, we're going to go ahead and make x cubed our input. So this is going to be cosine of x cubed squared times the derivative of this input value, which is going to be 3x squared. And that is another example of the second fundamental theorem of calculus, number 31. I hope that helps. Good luck.